We'll have a look at October 2013, question 1. It tells us that at 1800 we're at anchor north of Wahiki Island. There's Wahiki Island here. We're just somewhere north of that. The northern limit of the red sector of Maria Island Light bore 278 gyro. So here's Maria Island, the red sector light, and it's the northern limit. We're in the southern hemisphere, so of course this is the one we're interested in. That's the northern limit line there. That bore 278 gyro, and the Horohuru Rock and Tuao Point subtended a horizontal sextant angle of 112 degrees. So the 2 points here subtended an angle of 112 degrees. We need to find the latitude and longitude of the vessel at 1800 hours, the gyro error. Okay, let's look at the gyro error first. When we take this bearing here and we go with that bearing there to the compass rose, that is going to be a true bearing. Anything we read off the chart is a true bearing. So once we get that reading off the chart, we compare it to 278 degrees gyro and we can work out the compass error or gyro error. So off the chart we got 280 degrees true, 278 gyro, therefore the gyro error is 2 degrees low. We then looked at the horizontal sextant angle. It was 112 degrees, so 90 degrees minus that gives us 22 degrees. It's a minus, so we need to plot our triangle the land side because it exceeds 90 degrees. So looking at the chart, we ran the angle of 22 behind there, as you can see, put our compass on here, drew the circle, and where it cuts the bearing line, that is our actual fix at 1800 hours. So that's our fix at 1800 hours. Okay. Part B, the vessel's to depart the anchorage at 2000 and the passage plan is to pass 3.2 miles westwards of the Channel Island Light. So further up the chart here, I've marked the waypoint at 3.2 westwards. Our speed's 12.5 knots. We have a tidal stream given, height of the observer, met-vis, and we need to find the gyro course to steer at 2000 hours to make good the required course. So all I've done from our actual fix here, now we call this 2000, I've run the course we've actually got to make good up to our waypoint. From this position at 2000, I've run our tide for an hour, and then I've run our speed for an hour, cut our course line, and that will give us the true course to steer, allowing for the current, the tide. Okay, so we've allowed for the tidal stream. There's no leeway, so we simply got from the chart the course to steer was 022 degrees true. They'd asked us for the gyro course to steer, so we applied the error and it gives us 020 degrees gyro is the course to steer. So that's the first part done. The estimated range that the Channel Island Light will first be observed. Well, all we do on the Channel Island Light, we read off the elevation and the nominal range, 9 miles and 79 metres. We're given height of eye and met-vis, and then we just use our geographical range table with the height of eye and the elevation. We use our luminous range diagram with the nominal range and the met-vis, and that gives us our luminous range. We then compared the two distances we've got, and we use the least, which of course is off the luminous range diagram, and it gives us a range first observed of 13.2 miles. Then at 2100 hours, Channel Island Light bore 038 gyro at 8.5 miles. So obviously we then have to convert that to true and run that true bearing plus the distance, and that gives us our actual fix at 2100 hours. And it's asking us to state the actual set rate and drift. So all you do from the original position 2000, run the actual course you've got the helmsman to steer. So whatever course you're steering, run it from this position, and of course it's this first course line here that we've run off at the end of the current, the top end of the current. We run that, and we run that at the ship speed for the ship speed that we've been given, the 12.5 knots, and we run that for an hour, and we'll see that the difference between the two is very minimal, and that in this instance the actual set rate and drift, we just call it a slack tide. When there's virtually no distance at all between them, you would refer to it as a slack tide.